Hello, welcome to Geoscience Engineering and welcome to the course of seismology. In the previous video, we have discussed about the seismological waves, the types, the propagation, and how they are detected and how they are used for the studies like internal structure of the earth and structural studies and also earthquakes and hazard management. Now, when the waves or the energy is released, it should be detected by some instrument, and we call that instrument as a seismic station. So, like I explained in the previous video, that seismogram is the graph, and seismograph is the instrument that records the data. So, in these videos, we will discuss about what is a seismic equipment and what are the components of the seismic equipment and what are the purpose also. I'll explain you in detail. Now, we know that earthquakes are most common and they are like dynamic and destructive natural process in the earth. The first development of the seismic stations are done in 13132 CE in China. It's called a Zhangheng seismoscope, which is used to find the direction from where the earthquake has come. And after that, in 1800s, the seismological advancement has happened, and people started using this vibrational seismometers, through which the disturbance in the ground or the wave motion is recorded through the vibration. And later on in 20th century, Japan, Greece, and many other countries started doing many studies, and they started develop this digitized format of the seismograms. Now, around the world, like globally, there are many seismic stations installed, and every time when some event happens, this is being collected by the station and it is sent to the server. So multiple stations are collecting the data, and this is giving you the whole picture of where the earthquake has happened, what is the magnitude and what is the wave path travel time, and how far this waves has traveled, and what is the destruction. Everything we can find out. So the main purpose of the seismic station we are going to discuss now. The seismic station is equipped with instrument that designed to detect and to record and also to transmit the data. I'll show you a practical video of the seismic station also. First, let me give the introduction. So the primary function is to detect the earthquake. That means it detects any seismic event in the real time, and also the localization. That means determining the location, the epicenter, and the depth from which this earthquake has happened. And this will also do, like, to identify an earthquake, you need minimum 3 stations. So these 3 stations will give you a triangulation kind of processing technique, and then you can identify the magnitude and the epicenter and the location. And these magnitude estimation also will be done measuring the amplitude, frequency of the seismic waves, and then they calculate the earthquake magnitude. And these seismic stations are also used for hazard monitoring. Just like if you wanted to find the seismic hazards in a particular area, we call it as microzonation. So we take the instrument and we keep it on that location and see what is the time or how much frequently that particular point in the city is giving you the earthquake or kind of disturbance, and is this place suitable for construction, or is this place weak. That we can find out using these seismic stations. Now, when we are talking about the components of the seismic station are again different, and like I told you, there are continuous seismic stations and only permanent stations and only temporary stations. So when it comes to the components, we have seismometers, which are called as sensors, and these sensors are short period sensors in which you will have high frequency, which are used for sensitive nearby small earthquakes. And then we have the broadband seismometers, which captures a wide range of frequencies and are used for regional and global monitoring. and there are strong motion accelerometers which are coming with both the seismometer and accelerometer together, and these are used to record large near field ground motion that occurs during the strong earthquakes. This is mostly used for engineering studies. So typically this seismic station will have three components. That means it's oriented, it has collecting the data from three different directions. One is the vertical, the other is the north and south, the other is the east and west direction. These three components will give you the structure like a 3D ground motion, 3D motion of the ground. So when it comes to the data acquisition, we need to have a recorder. This recorder is generally giving the analog data and it is converting it into the digital data, and then it is giving you in the numerical values. And then we have the clock system in which the GPS is gathering the information of the latitude longitude, and with that you are getting the data and the time assigned together, so we get the exact location and the time of event. And then data storage. When it comes to the data storage, these seismic equipment or the seismic stations, they come with internal storage, like they have a USB stick in which the data is stored, and it will be overwritten every 5 days or any other frequencies. And also some stations are directly connected to the server, so that the data will be sent directly from the instrument to the server, and these will be stored and the records will be stored for a longer time. And then the software controls, in which you are going for the calibration, data formatting, and if you want to check the diagnostics, you can use the software, or sometimes you can use the web interface to find out or to control your seismic equipment. And coming to the power supply, like I told you earlier, if you are installing the seismic station in a remote area where you don't have any kind of most access to the people, there you can install the seismic equipment, and then you can power the station with a solar panel. And sometimes when you are installing it in somewhere near to the, say example, government organization or any education organization, you can give the power supply through the main system. And most importantly, you need the backup also, because this backup generally comes with the battery or a rechargeable battery, so that once there is a power loss, at least this battery can give some backup, so that the continuous data transfer will be successful. And then when it comes to the communication, some people are using this satellite communication like VSAT, and some people go for the cellular or micro radio links. Even you can use the routers with the SIM card, so the SIM card will provide you the internet, and that this instrument will take the data and it will send the data to the server through this internet. And also we need to make sure that these equipments are not exposed to the harsh nature, so we will have to do some protective covering, and this also I will show you. And then we'll just go into detail of types of seismic stations. In these seismic stations, the permanent seismic stations are installed for long-term monitoring, and usually these are made by the USGS or IRIS. They have continuous monitoring systems, so these are permanent stations which are fixed all around the world. And then they are also located in some geologically stable and no noise environment. And when it comes to the temporary or portable stations, they are used for short-term studies, just like once there is an earthquake, you will have a wave vibration, and we call it as aftershock monitoring, or any kind of field service we can use that. And these are very easy to deploy, and these are generally used with arrays. So when you go for a geophysical exploration for the oil and gas, you put the geophones in an order, in an array, and then you give the shot, and then that will be recorded, and it is used for finding the internal structure of the earth. And the other type is strong motion stations, in which these are generally installed in places where there are industries and huge number of people, like population. So these are used to record large ground accelerations, and these are used in the engineering seismology to improve the building codes and the designs. And there are other type of seismic stations called borehole seismic stations, in which the sensor is installed or it is fixed some meters below the ground, so that you can get more and more high quality information, even useful for crustal and also the fault zones. And then we have the other type, it is ocean bottom seismic stations. The name suggests that these are installed at the bottom of the oceans to study the mid-oceanic ridges and the subduction zones. And then we also have the volcanic seismic stations. These are placed around the active volcanoes. They detect the magma movement, the gas explosion, and any kind of tremors that the volcano generates. And this is essentially for volcanic eruption forecasting. So these all seismic stations generally together, they call it as a global seismic network, in which the stations can be grouped together as a global seismic network, international monitoring system. And when it comes to the regional network, you can have a Indian seismological network. And if you are going for a local network, that means it is dependent to only your education institute or only to your office. You can use that for earthquake hazard assessment or shock studies and volcanic monitoring, and also urban seismic management. Now if you see if you see how a seismic station works, first is recording the seismic waves. When the earthquake occurs, seismic waves radiate energy outward. A seismic station which is having a seismometer will detect the ground motion, and it converts into the electric signal and it records into a seismogram. This graph or the plot is amplitude versus time. That means it will show you the amplitude of the wave and the time in which it has come. This is done by the recording instrument, and the time synchronization will be given by the GPS, and the data transmission will be done by the seismic station through different servers like Seiscomp or Earthworm or even Antelope. So these are used to identify the P waves and S waves, to detect them and to find the difference between the P and S waves, arrival times, and then from that we can identify the magnitude, we can identify the direction, we can identify the time. These are all done in this seismic station, and data recording at the seismic stations is more important. In the seismogram, we'll have the P waves, just like we discussed in the previous video. P waves are the first to arrive at the seismic station, and then comes the secondary waves, and then comes the surface waves. So we can have a clear look of the seismogram data in the coming videos. Then I'll show you what is the P wave, what is S wave, how we can identify in the seismogram also. And this particular seismic stations need the metadata also. Metadata means the location, the name, the instrument gain, and also the calibration constants are also needed. And most importantly, we need to discuss about the data formats. So in the coming videos, I will also explain you about different kinds of data formats and the comparison and what each file will have. Then we'll go for this three components also, and I can show you clearly the particle movement from the vertical motion, from the east and west direction, from the north and south direction in the next videos. So please do stay tuned for this geoscience channel, and then watch the all videos in this seismic course, so you can have a better understanding about the practical understanding about seismology and the components used in seismology and how the data is being interpreted in seismology. Thank you.